modular, and this is called booster.
I
Process is you have to switch on.
have one query. Here on the bottom, the gas circulation is happening. Na? This we are keeping the booster on the top. Will it affect the heat
No,
circulation?
backside it is there.
Or if needed, we can use that area also, and we can the corrosion. Huh?
Backside it is there. Fan is there.
Fan is there. Okay. So in the bottom, here there is no issue, right?
No issue.
Okay.
Still little bit gap is there for air ventilation. Backside is fan is there.
Yeah. No. What I'm telling is, if we can keep there also.
No, if it will keep there also, still it will touch to the surface, no?
No. Actually, here in the top, I have seen some ventilating area. So this heat has to go out. Na?
Here nothing, no hole is there. Here, no, you are telling this one.
On the top.
No, it's not there.
Not there. Okay.
So this is the power on button. This one and this one.
Yes.
Then this is cell on button.
Okay. This is booster on.
Booster on. Okay, you can see the cables. It came from one to this cable. Okay.
Okay. Left cable contains red and two pins. Left cable, 2 pin.
It's not left, right. You can mention this cable came from booster only.
Okay. Booster.
From booster 2 cable, one is counter, one is working.
One is counter and another one is
It's written C. C means counter electrode.
Okay.
W means working electrode.
So in general, the red is counter, right?
Red is WE. Red is WE and black will be your counter.
Black will be counter. Okay.
It is mentioned in mark. Black counter. Okay. And here contester this one cell. Green is your earthing. Symbol also there.
So that you call it as
Earthing.
no. This particular wire, what you call?
All are cell cable.
Okay. So this one, this you call it as what? Tester.
No.
This
This is
one.
booster. The booster actually adapter only.
Okay.
Booster set adapter. Booster adapter. For this booster cell adapter. Booster cell adapter.
Booster cell adapter. That is on this connected to the left side. Okay.
From there you have 3 connectors are there. One is red. That is called sense.
Sense.
AC and AC. Sense electrode.
Sense. Okay.
Blue is RE. RE means reference. It's written also RE. And green is earthing.
Yeah. Okay.
This will always combine together. Red and red. Then only it will combine it will work.
Will it be connected either way or
Anyway.
This on that on this. Okay. So
This will overall your working electrode. You can connect like this also.
okay, red and red should be connected.
It should be always connected together.
Okay.
This has to connect your HGCL or calomel electrode, reference electrode.
Blue one has to be connected to HGACL.
That is you don't have. Leave it there.
You are going for AGCL and calomel.
HG will come with the basic cell setup. This will come, na? And glassy carbon will also come electrode. That is working electrode. Okay. So basically for our electrochemistry, what is the electrochemistry? Electrochemistry basically one solution will be there, and with respect to solution we are passing the current or potential with help of 3 electrodes. One will be your counter electrode, another will be reference electrode, another is working. 3 electrodes will be there, and we are passing the potential or current. So where current will apply or where potential will be applied. Current will measure. So in between your working and counter, current will be occurred. Means current measurement or current apply in between that only. Working and counter. सब लिख सकते हैं. Working and counter.
Working and counter, okay.
Don't write like that. It is very difficult to understand if like this. एक्चुअली ये डब्ल्यू करना चाहिए था, इजी रहेगा. ठीक है, ये आपका हो गया पोटेंशियल. इन बिटवीन वर्किंग एंड काउंटर इट विल बी आई मीन्स करंट. मतलब आप यू हैव टू अप्लाई करंट और यू मेजर करंट इन बिटवीन दिस एंड पोटेंशियल भी ऑफ कर इन बिटवीन दिस.
Take the class. C is you call it as
You can write the short form. You can C means counter electrode.
counter electrode. Okay. In this case, the counter electrode is not there, right?
Graphite.
Graphite, right? Yeah.
Graphite. You already written HgCl and calomel and this one. For counter, there are 4 types counter is there. One is graphite, another is stainless steel, another is platinum.
Stainless steel, platinum. Okay.
Basically, 3 types. Gold is also there, but that is very rare. That is piezoelectric cell only there, not in all cases.
Okay. So counter electrode and this work electrode
These
is
inert materials, all are inert materials.
all are inert material.
Yeah, that are gold, platinum. This current will be
it's like noble metals.
noble metals.
Noble metals.
Because current requires less resistance.
Good conductor and less
Good
resistance. Okay, fine. This WE is
Working.
electrode. In this case, working electrode.
Yeah, you please write working electrode. Working electrode can be your sample. Sample means which you have prepared, which you are going to analyze.
Sample.
Like one
Aluminum,
magnesium. For him it is magnesium. Maybe he can prepare your
copper, aluminum,
copper.
copper.
Okay.
This working electrode sample.
Sample.
They have kept 15 by 15. Does it need to be 15 by 15 or it can be more?
Yeah,
also?
I am coming to that point. Sample. Otherwise, you can use glassy carbon if it is a liquid item. You don't have the solid item.
Glassy
Carbon electrode, that is short term GC. That glassy carbon also can be a working electrode.
This glassy carbon electrode can be used if the material is liquid.
Yeah, you have to liquid items for liquid items only. This depends upon your actually clearly your analysis. Then glassy carbon liquid item.
Now
And there are several working electrode. People are using platinum also as a working, silver also there. Different element, different.
Actually, I am asking. So in the electrode which we have procured, it is only meant for solid material, right? The
No, not
basic electrochemical cell.
That is glassy carbon will be there.
Glassy carbon.
And for solid you have to prepare the sample.
Okay.
In that also you have to you can use your sample. Liquid items also people can use their own sample as a working. Doesn't mean that always glassy is required.
Okay.
Okay. So bring that one, we will show that one.
Here in this case, what will be the reference electrode?
The reference electrode is the calomel.
Calomel. In this case, it's calomel, right?
सर उसका मैक्सिमम कैपेसिटी कितना है?
वो डीप होना चाहिए पूरा. डीप हो रहा है?
और लाएं?
नहीं ना, हो गया लग रहा है. ये आपका वर्किंग एलिमेंट डूबना चाहिए, पानी में टच होना चाहिए और कुछ नहीं। हो रहा है मेरे ख्याल से, हो रहा है। इस तरफ देखिए, उठती लाइट थोड़ी तो थोड़ा हो रहा है, इतना तो आएगा थोड़ा काउंटर।
हाँ सर वो है कहाँ सैंपल सर, वो नहीं दिख रहा है मुझे।
सैंपल है ये इधर है।
तो डूबा है। हाँ तो यहाँ तो आ रहा है शायद। No, I think sir more water required.
More water required. You can add another 100 ml or 50 ml.
थोड़ा चलेगा, अभी देखते हैं, नहीं होगा तो करेंगे। थोड़ा ऐड कर देने से वाटर अच्छा होता है।
तो कर लाते हैं ना सर।
देखिए
Electrodes are dipping.
इलेक्ट्रोड डीप है, यहाँ पे वर्किंग है ना, वो डीप, जितना डीप हो रहा हुआ जाएगा, थोड़ा सा ही डीप होता है वो चलेगा।
No, actually I think
ऑलरेडी सर हो गया, मैं देखा हूँ डीप है।
it is dipping only.
ये वाला जो साइड में है ना, वो ऑलरेडी कॉन्टैक्ट में है।
होल जो है ना थोड़ा सा,
ये वाला सर जो मैंने सिम आया है वो आया है कॉन्टैक्ट में।
So my question is, now we have given 250 ml. Can we give 300 ml instead of this?
Yes, you can fill up to there. There is no problem on that.
Okay. Next time we have to go for higher.
ये बाय रेड में रेड।
रेड में
Can we keep the bag there? Okay. This one can be connected anywhere, either way. No problem. Okay.
ये कनेक्ट कीजिए।
किधर करें?
बताया था आरी को आरी में लगाना है, लगाइए आरी को आरी में। कंप्लीट नहीं होगा तो ये काउंटर हो गया।
Black to the. So it is mentioned there, no? Your counter. Huh?
यस मैं समझी, ये आपका कनेक्शन हो गया।
इसका क्या उपयोग है सर ग्रीन वाले का?
ग्रीन ना अर्थिंग है, जरूरत नहीं है, नहीं तो आप यहाँ पे डाल सकते हो बॉडी में।
हाँ ठीक, कोई नहीं।
जरूरत नहीं है।
हाँ। यहाँ लिखा है ना, लिखा है वर्किंग, रेड वाला वर्किंग है, CEA है, ठीक है। सैंपल इधर कहीं लगा हुआ है, यहाँ पे बीच में वो जो लगा है ना बीच वाला सैंपल 15x15। ओके ओके हाँ
वो ये जो रेक्टेंगल जैसा है, क्यूब है,
मैग्नीशियम है ना।
मैग्नीशियम वो उसी की जैसे।
You are PhD student or a
Yes,
PhD? Working under?
Dr. R.N. Rai and Dr. B.
Yes. Yes. Software, no? Yes.
राहुल में होगा।
Screen record है सामने।
It's a screen recording on कर। Audio will not be recorded, na?
Go to open level, then go to LSB, linear sweep autometry.
You're going to library, then you're opening linear
sweep autometry, and then linear polarization for corrosion study.
Library linear
पोलराइजेशन फॉर corrosion।
sweep. And linear polarization.
Double click. Go to auto lab control.
Sorry, setting.
ऑटो लैब कंट्रोल।
Then adjust the current range.
Auto lab control.
What is the minimum and maximum?
Adjust current, okay.
Minimal 10 nanoampere or highest 10 ampere booster.
So actually, this regarding the current range,
Hmm.
is there anything like we have to give? If we give maximum, any issues will come, or if we give minimum, any issues will come.
No issue.
So depending on that, the reading rate will be different, right? When the more
Yes,
current is there, the reaction will
If
be
reaction is more is there, then you just put more. Otherwise, you keep it by default. Put in 1 milliampere, 10 milliampere. That is sufficient for electrochemistry. 1 to 10 milli more than sufficient.
Yeah, that's what
Unless you don't go for booster.
Okay.
Unless it is required, don't go for the booster.
Booster. Okay.
Suppose you are analysis in 1 micron is and you are doing booster 10 ampere, you will get lots of scaling error. You will get.
Okay.
It's like that. Suppose your balance wave capacity is in terms of turn, and you want to measure it to 1 gram. How it will be?
Okay.
It's like that only. Suppose
So in general, we have to go with this 1 milliamps and 10 milliamps for the operation procedure.
yes, that much is sufficient for analysis.
So only when we go for the system like battery and other things, we may
Battery
have,
you require energy means you need booster.
then we have to go for booster. Okay.
I think, sir, that milliampere will be mentioned in paper na, for particular sample.
No, that is different thing.
Yes, sir.
It's here I'm telling you maximum current is. You are telling that is you have to apply that current. That is both are different.
Okay.
Okay.
That is for measuring the.
I am coming to that point.
Okay, sir.
Okay.
Go to the LSB staircase directly.
So in continuation with this,
Yes.
you have given 1 milliamp, then you have to go for LSB staircase.
You can go to the OCP or write it down OCP.
OC.
Open circuit potential.
Okay.
So it will measure the first potential in between your working electrode and reference electrode. Without applying anything, it will measure the potential of your total cell setup.
Okay.
Okay. Means we have not applied any potential or current.
Okay.
That is called open circuit potential. Without applying any current or potential, it will measure the potential of the circuit.
What is the capability of the system? Electrolyte with
इलेक्ट्रोलाइट के साथ आपका सैंपल का क्या
cell का.
क्या पोटेंशियल आ रहा है, दैट इट विल मेजर.
Okay, so in that case, no need to give. So I'm asking you. We are giving the current as 1 mil. Initially, we have set the current as 1 milliamp currently. After setting the current as 1 milliamp, or even without setting the current as 1 milliamp, we can go to OCP.
That for underage, there is no relation in between that.
There is no relationship between this and
It
that.
has not started yet. It will start from here. Cell on.
Okay. So OCP will give us the potential of the system. What reaction is happening? Based on that, it will give the potential, right?
Yes.
Okay.
It will measure. Suppose multimeter you are measuring the potential of that 2 is there na? What it is telling? 230 volt.
230 volt. Yes.
Why it is 230 volt? Because your power is on. If it will off, it will 0 na. Still it will give some voltage.
Yes. Those systems. Hello, sir.
In OCP you have to put the how much time you want to duration. 60 seconds or 30 seconds you can put.
Duration. Okay. So we can give in several minutes also, no?
Yes. You have to give interval second only here.
Second only. Okay.
Interval time means in that time it will record the data every 1 second. Okay.
So only these two data we will give here.
This data is required.
And this
Average OCP not required. Last OCP it will take. What is the last potential it measure? It will take that one only.
Use average OCP, that is not required, right?
Not
if you want, we can go for average OCP.
If you want to go, you need the average.
Except on dE by dt limit, it is mandatory, no?
That you can, means if it is stable, it will stop automatically. It will not go for 60 seconds.
Okay. So
d by dt means this much of changes is there. It's a very minimal change, 10 to the minus 6 volt. Means 1 microvolt.
Okay.
Suppose it's measuring 1.3 volt, and that much changes also not there. You understand? 1 microvolt changes also not there. Then
it will be stabilized.
Means it's stable means it will not go for 60 seconds. It will
Automatically cut off.
It will automatically cut off. Then directly go to LSB staircase.
Okay.
Here you have to put the start potential and stop potential. From this which range to which range you have to do the analysis.
OCP is over, interval time was over, dE by dt limit will be on. So that value is we have to always go.
That is a by default value. No need to change that one.
No need to change anything. Okay, fine. Then after that we are going for this one LCV.
LSB.
LSV. Okay, LSV staircase. Yes.
Then put the start and stop potential, change it.
Start potential minus 0.1. Stop.
This is not fixed. It will change as per your requirement.
Okay, so we have to change it accordingly.
Maybe you need minus 0.1.5 to 0.15. Maybe minus 0.2 to 0.2. Okay.
So now we have to, I think we can give slightly more
minus
voltage.
250 to plus 250.
ठीक है.
हमारा मटेरियल है ये थे मैग्नीशियम में minus 250 millivolt to minus
Minus 250 millivolt means minus 2.5.
Minus 2.5 volt is very high.
No, minus 0.2.
Minus 0.25. 0.2.
It's a 0.25 na.
Plus.
This is scan rate, 1 millivolt per second.
Okay.
That I think one understands. This much speed it will do, and with this much step it will record the data.
Okay.
And वो डेटा कहाँ से मिलेगा?
वो पेपर से वो आपका अपने
I started from here.
You started?
From here one that button na.
Oh, you have pressed already.
यहाँ से प्रेस करेंगे.
But there was one more icon which you had cell on. That is different.
Here na cell on. It is not required to do anything. That is a command only.
Okay. But what is the role of this cell on icon?
Without on the instrument, how it will do the analysis? It's like it will on the cell internally.
Okay. So do you have to do anything in this particular
No.
icon?
No. That's why I omitted that one. You have to do here, and then directly here, there. These things are not required.
Okay. So now it has started.
Here your OCP is still very high. I don't know. For your solution, maybe NSL, KSL is not required. KOH maybe. इतना ज़्यादा उसी minus 1.6 वोल्ट तो corrosion कैसे होगा इसमें?
हमारा सॉल्यूशन KCL है चलो NaCl है चलो नहीं ना
इसमें
NaCl दिया बोलो चलो
कितना परसेंटेज में?
3.58% गोटा में कैलकुलेट
तो इसमें तो नहीं होगा अभी 1 मोलर में वो इतना हाई OCP है तो वो आपको लगेगा उसको कंसंट्रेटेड NaCl लगेगा इतना लो में नहीं होगा वो कुछ भी नहीं होगा
3.58%.
हाँ तो परसेंटेज में वो नहीं होगा मोलर में.
Actually, what you are observing, sir. Now you are telling that it cannot do any corrosion.
Their OCP itself minus 1.6 volt. I mean suppose you are measuring without doing anything. See its power is there. That's why 230 volt is showing. If you power it up, main switch will go off. Then what is the voltage? Zero na. But still it is not coming zero. It is giving suppose 2 volt. Then what do you think? Some leakage is there in my line. Simple thing is here. Here is electrochemistry. Everything has some potential is there. It cannot be zero. Zero means it's wrong. Means short circuited is there. So their element itself is giving 1.6 volt.
Oh, that.
It's very high. We have not applied in this still it's 1.6. To corrode that surface, we need a little bit corrosive element, corrosive environment like NaCl, H2SO4. So we are given 1 molar KCl or NaCl. Both are same. But as for him, he told na 3.5% is NaCl required.
So that means what? It's 3 molar.
Not 3 molar. Percentage is very high compared to molar. Na?
In 100 ml, 3.5 weight percentage NaCl.
Okay. That means you 100 grams you will put 3.5 gram of NaCl, right?
So here there will no this thing will happen. After reduction will not happen. May not be. You need a little bit higher concentration to corrode that magnesium surface.
Okay.
सर कितना देर टेस्ट चलेगा ये?
आपने जो दिया जो टाइम 500 सेकंड चलेगा. -0.1 to 0.1 कम लगेगा. अभी -0.25 से 2.500 सेकंड लगेगा.
एक माइल्ड स्टील का ब्लॉक काटना है.
बट काटने से नहीं होगा. आपको स्मूथ भी करना है ना.
पॉलिश भी करना पड़ेगा.
बिना पॉलिश में नहीं आएगा, हाई करंट हो जाए, करंट ओवरलोड दिखाएगा, एरर कर नहीं पाएंगे आप। इसका तो स्मूथ है, मैंने सुना हुआ थोड़ा बहुत, बस उनको सॉल्यूशन चेंज करना है, उसको कंसंट्रेट देना है। 1 मोलर तो NaC हमारा ये सॉल्यूशन स्टेनलेस के लिए हो जाएगा, माइल्ड स्टील के लिए। माइल्ड स्टील तो बहुत स्मूथ रहता है ना।
डेटा स्टोरेज माई डेटा, ठीक है, इसमें जाइए।
टाइम चेंज होना चाहिए, नहीं हुआ है वो सेट टाइमिंग ऑटोमेटिकली नहीं थी इसलिए। कितना टाइम होगा?
3:10 टाइम सेट करना।
ये आ गया टाइम के हिसाब से आपका डाटा है, इसमें डाल दीजिए कि मैग्नीशियम ना। डाल दे, सपोज एम जी सैम्पल, एम जी कूपन डाल रहा था तो एम जी डाल दिया मैग्नीशियम। आप लिख सकते डायरेक्ट जो भी चाहिए, रिमार्क्स में या एन में, किसी में भी।
Linear polarization, okay.
तो इसका डाटा कहाँ पे आता है? ये सब डाटा है एक और पे, इसका डाटा भी यही पे आता है शो डाटा में। ये आप एक्सपोर्ट कर सकते हैं CSV और एक्सेल में,
हाँ.
रख सकते हैं कहाँ पे भी।
You create a folder sir, in data.
नहीं नहीं, जरूरत नहीं है।
हाँ.
आपको चाहिए तो ऑलरेडी डाटा सेव हो रहा है,
हाँ, ठीक है, ठीक है.
दो बार क्यों सेव करेंगे आप? आपको अगर लेना है CSV फॉर्मेट में कहाँ पे, तो आप ले सकते हैं, डाटा ऑलरेडी इसके अंदर है। यहाँ पे सिर्फ लाइन बाई लाइन आ जाएगा, 1000, 10,000, 15,000 डाटा आ जाएगा, जब चाहिए आप डाटा ले लीजिए वही से।
ठीक है, एक मिनट सर. My data it is stored. Okay,
Yes,
fine.
it will come to the my data only.
If we want to export it to Excel, where you said somewhere we have to press, na? Where we have to press?
Let's open the data.
This one.
Hmm.
Here, this one.
Hmm.
Then this one.
Yes, then export.
This one. Export. Then we can store it wherever we want.
Yes.
Okay, so this in the Excel we will get a graph like this. Okay.
Excel will not get, that is the raw data.
No, no. When we brought it into the Excel, this data will come.
Can we export the graph, sir?
This format.
Just a minute.
They zoom it.
Then double click we have to do. Then we have to go here. Then this button you have pressed, right? This one.
Left.
Export image. Okay. We can take as JPG or whatever it may be. I'm asking you here. This one we have done. By doing this TOEFL analysis, we have got everything. Okay, so this is the only procedure to get all the data. And what we can get from this type of this graphs and all, this is nothing.
Not
Whether
reversal, just simple OCB only.
This graph doesn't have any.
D by dt, and this is a OCB.
So it cannot be used for analysis purpose, right?
Doesn't require.
Okay. But this data will be there. If you want, we can take
If
it.
you want, you can take it. Always data can be taken from here.
Sir, can you discuss something about Teflon curve, sir?
TOEFL.
Teflon curve.
What discussion you want to know?
मतलब वो क्या बता रहा है, कैसे बता रहा है, क्या शो कर रहा है?
वही तो बताया था, आप नहीं थे, सर वो नहीं थे।
You are not there.
You're not there, ना?
No, actually, what they are telling that particular curve is the procedure to get all the data, the correction, I correction, J correction, all these things.
Yes, sir.
So
See,
there,
I am telling.
Yes, sir.
This draw also you know ना, और that time you know not there.
सब बताइए बेसिक से जो भी है, मतलब
नहीं नहीं, बेसिक करने
मुझे कुछ नहीं आया।
फिर 15 मिनट लगेगा फिर ड्रॉ करने में, आसान नहीं है।
सर समझा दीजिए ना कम से कम अच्छे से।
चलो समझा देते हैं, कॉर्प मिडिल में आना हर बार में इजी नहीं रहता है। यू हैव टू डू हिट एंड ट्रायल, देन ओनली यू गेट द मिडिल वन।
जो मिडिल में आएगा तो मतलब अच्छा रिजल्ट आया, कह सकते हैं।
You have to take more, it has to cover more maximum time.
actually, this curve which we are plotting, it's like trial and error.
Yes, sir.
Ultimately, this curve should come in such a way that intersection point is almost in the center,
Yes,
And this has to cover the more
and
points.
the line should cover the more points in the
Tangent line.
curve.
Okay, sir.
So this
Then
is
it will be more specific.
Okay, sir.
Otherwise, you can give any data also. That is not the data it will give.
Yes, sir.
See, first thing you have to put the surface area.
मतलब इसका एरिया कितना था सैंपल का?
कितना इसमें 1 सेंटीमीटर हो रहा है तो 1 सेंटीमीटर दीजिए।
हाँ
इक्वल एंड वेट आपने दिया है, मैग्नीशियम का नहीं दिया, जो गलत डाटा इसलिए दे रहा है आपको एमएम पर ईयर ना। मैग्नीशियम इक्वल एंड वेट देने का है, आपको डेंसिटी देना है, तभी आपको ये कैलकुलेशन सही आएगा। ये जो आपका इक्वल एंड वेट इज नॉट अ मैग्नीशियम, दिस इज आयरन। डेंसिटी ऑफ आयरन इज 7.83, डेंसिटी ऑफ इक्वल।
What is density of magnesium? What is the density of magnesium? 1.6 na?
1.84.
1.84.
ओके। इक्वल एंड वेट
गूगल का ना 20
सर देखिए ऑलरेडी चेंज, इट विल चेंज अ लॉट।
That's what it is.
Taking the
That is the important thing. Na? So equivalent weight. What is the equivalent weight? That particular area. What is the weight involved?
Put in Google, it will come.
एकदम है यार।
Molecular weight divided by valence is equal to equivalent weight.
24 points.
That is chemistry. You just type in Google ना। कितना equivalent weight?
डायरेक्ट बता देगा।
24? 24?
24.312.
সেটাই তো বলছি। Molecular weight divided by valence magnesium কত 1 তো।
Molecular weight.
Oh sorry, 24.312 divided by 2.
কত আসছে বলো?
12.15156.
कैलकुलेटर में भाग देगा।
देखा सर कितना चेंज हो गया। 12 है, ठीक है। 12 है,
तो यानी 24 ही।
ठीक हो सकता है। मैंने इसका 2 बैलेंस है ना।
बैलेंस है 2.
So after plotting this curve, we have to do the entry, right?
हाँ, there is come wrong ना। Now 1.8533.
Yes, for us it's a combined alloy. You need to find out how to find the, because you have aluminum and copper put together.
See, if it is combined, then you have to take the dielectric.
हाँ तो सर इसका कैसे करेंगे डाइलेक्ट्रिक का?
वो तो मुझे पता नहीं, आप इसका
सर पॉलिश है सर।
ये तो आपको निकालना पड़ेगा डाइलेक्ट्रिक। मुझे इसमें थोड़ी ना मेजर हुआ, इसमें डाइलेक्ट्रिक मेजरमेंट अलग चीज़ होता है। आपने जो बनाया उसका डाइलेक्ट्रिक आपको पता रहेगा। ठीक है, दोनों एलिमेंट मिला हुआ है
एल्युमिनियम कॉपर।
तो इसे कैसे मिलाएंगे आप इक्वल वेट?
You have to iterate and you have to find it out.
हाँ,
So this can be deployed here, na?
it has to deploy there. But finding is that dialectric is a different thing. With combined, na, you have to deploy that.
Yeah, you have to use some equations which is readily available. Maybe some theoretical models will be available to find out the equivalent weight of weldment. It is also quite interesting. After finding that, then you have to put the data.
Actually, another it will change na. See, where is 0.9 and where is 1.8, double na, 2x na.
You may have to go in the aluminum side separately, copper side separately, and in the combined area separately, and you have to find out some
Combined one.
combined one. I think you will get.
I think you will get that is just the theoretical process will be there. That is not that much of a difficult job.
Maybe there may be some correlation between the compositional analysis and the equivalent weight. You are doing EDAX now.
Yes.
After doing the EDAX, that from the data you have to corroborate here. Some indirect way of finding it will be there.
Yes.
Then the real work is there now.
Yes. सर जो पेपर आज तक पब्लिश हुआ एल्युमिनियम कॉपर पे ना सही नहीं हुआ है सर। They did some manipulation sir.
No, actually, I am asking you. You said that the moment we put automatically that the second one, when you are going for this one, directly OCP will show some potential, right? So is it from there also we will be able to
OCP
get.
it will be started working when you will dissolve in the water, means solution. Open you cannot measure it. Open how will you measure it?
Say it again.
OCP will be measured when you will complete the cell setup. You cannot measure it. Suppose just like that will bring and will connect some cable. It will not do any. It will not work.
Okay. Now the thing is, now the experiment is over. Now the experiment is over. This data is not there. This graph I can take it out and I can change this value and I can reiterate accordingly. So that is there. So what my opinion is, you may have to do it for aluminum separately, the potential thing.
Yes.
And copper potential thing you have to evaluate.
Yeah,
And
अच्छा
for
है,
this also you have to evaluate the potential.
ये आपका इंटरेस्टिंग आएगा डिफरेंट मेटल का देखने के लिए। अब लिख के रखिए तो सर अभी आप कंपैरिजन अभी भी कर सकते हैं. You can compare ना. Now suppose you get के था वो.
This is magnesium.
You have to measure two things, sir. Huh? Polarization resistance is very crucial parameter. Just remember that one.
Polarization resistance. Yes.
Very crucial parameter. Corrosion rate is not crucial. Resistance is a crucial parameter. If the resistance will be higher, your corrosion will be very less. Resistance high means it will resist, na? It will resist, so your electron will not flow, so it will not corrode. If resistance is very lower, so corrosion definitely will happen.
So this polarization resistance also depends on equivalent weight only.
No. That doesn't equal.
Can you just change it to 24? This equivalent weight.
Polarization resistance is different thing. It will measure from current and potential. It will not do any area or equivalent weight. Density equivalent weight is required is for corrosion calculation.
I
Nothing
understand.
else.
So can you just change it to 24?
Nothing will change.
So you may have to go with polarization.
Polarization resistance. That is
Yes.
yes.
This is calculation is for your corrosion rate only, equivalent and density. Polarization resistance is your system generated. It cannot be changed.
Sir, we should claim corrosion resistant based on corrosion.
कितना 12 point कितना था?
Polarization resistance.
12.156.
क्या आप बता रहे थे?
Sir, actually what he is telling is, we will indirectly claim that corrosion resistance is good by stating that the polarization resistance of the weldment is better compared with the parent metal.
Yes, correct.
So by that way we have to come.
Yes.
But you can also find out the
Polarization SM is simple, the working electrode resistance. This is working electrode, na? This is what is the resistance. Measure it. Technically, theoretical, tell me, magnesium will be better or aluminum will be better?
Aluminum का magnesium will be better.
Theoretically.
theoretically yes.
But in that case also matters surface polishing. If it is more rugged, means not polished, so high current area will definitely be increased, your current will pass more. In that case, sometimes you will get maybe higher corrosion. So make sure both the surfaces are properly polished. Then only you can compare it. You cannot compare just unpolished and polished surface. Hell and heaven difference will be there.
So the roughness also plays important role.
See, roughness will be there means definitely area will increase, na?
Yes.
This is the plain area suppose.
मतलब पॉलिशिंग सबका एक समान होना चाहिए, सारे सैंपल का कंपैरिजन करना है तो
हाँ, नहीं तो प्रॉब्लम आ जाएगा, आपका स्टडी गलत हो
रिजल्ट
जाएगा,
में वैसे वेरिएशन है,
रिजल्ट आपका गलत हो जाएगा, एरिया गलत हो जाएगा तो
रिसर्च कितना माइन्यूट है.
That's why this machine is this much expensive. Now we need to purchase roughness meter also. Actually, the micro ohm meter is coming. There we can directly measure the resistance of the sample.
Actually, in steel industry they are measuring that smoothness, all this I see. It's like that Timken and Tata Steel, I have went there, they have different machines to measure the smoothness they are doing, na? Polishing they are measuring.
They will use the roughness test, the surface profilometer.
Surface meter something.
Surface roughness meter.
But that is not required for research, I think. But for commercial only.
No, I think it may be required here.
No. You need just a polishing paper only, take it, different one micron, 400 micron, 500 micron, more micron means polish will be more. Start with from lower, 60, 70, 500, keep it and polish it and do it. Nothing big job is there.
So both sir is having surface meter.
Very cheaper also, in just
Not working, sir.
Not working.
Working.
It's a very
अभी इसको डालो माइनस.
ये impedance
अच्छा इसमें इम्पीडेंस करेंगे, इम्पीडेंस कर देते हैं.
सर इम्पीडेंस का सलूशन अलग रहेगा कि
सेम है, अलग क्यों रहेगा? मैं करके पहले देखता हूँ.
Actually, I am asking you, the polymeric samples having the graphene and other things, which is slightly conducting, not is perfectly conducting. Maybe I can call it as semi-conducting material kind of thing. Beyond a particular threshold, it behaves like conducting material. Can we see its potential by placing it in the sample?
कर सकते हैं. इससे ज़्यादा आएगा मेरे ख्याल से. मैग्नीशियम में से कम आएगा मेरे ख्याल से.
सर इसका कर देते हैं जॉइंट
உங்க
का
சாம்பிள்ல வந்து
वो
நீங்க
नहीं है।
तीनों का सर
இதை
टाइम कितना
போட்டுட்டு
लग रहा है
இதோட ரியாக்ஷன் எப்படி இருக்குன்றத வச்சு இதோட
Potential
அந்த
gap है ना,
growth
minus
கம்பேர் பண்ண முடியுமா
ऐसे कितना है?
हाँ सर ओके ओके
एल्युमिनियम
तो इसका ऑक्सीडेशन ना पता है तो मुश्किल है। आ जाएगा।
এটা তো ডাইলেক্ট্রিক এটা
டேட்டா நமக்கு வரணும் சேஞ்ச் ஆகி ஒவ்வொரு
Dielectric
டேட்டா வந்துச்சுன்னா நீங்க அதை வச்சு நம்ம கம்பேர் பண்ணி
फैक्ट्री ना
கொலாபரேட் பண்ண முடியுமான்னு பார்த்து பண்ணலாம்
জাস্ট পোলারাইজেশন রেজিস্ট্যান্সটা দিয়ে বার করতে হবে যে রেজিস্ট্যান্স বেশি বেশি থাকলে কম ইয়ে হবে আর
Resistance বেরোতে পারবে,
হ্যাঁ ওই রেজিস্ট্যান্স দিয়ে এটা নয়তো ইকুইভ্যালেন্ট বার করা ইকুইভ্যালেন্ট বা ইয়ে বার করা চাপ হয়ে যাবে ইকুইভ্যালেন্ট ওয়েট কারণ নাহলে ওই x টু দি পাওয়ার কত পার্সেন্ট ওয়েট হয়েছে x টু দি পাওয়ার
Have you went to impedance?
मैं देख रहा हूँ इसमें इम्पीडेंस मैं बता दूंगा इम्पीडेंस कंपैक्ट होगा या नहीं होगा फिर देख लेगा मैं तो नॉइज आएगा। ये गलत हो गया कितना ओसीपी था उसका बोलो पहले
কোন এটা ইম্পিডেন্স এর কি
ओसीपी को तो चिलो आगे जस्ट माइनस ओसीपी ऑलरेडी इंक्रीज ना always do impedance first then go for corrosion first you will do the corrosion na the surface will be resistance will change then impedance study will be wrong
First do impedance, then
minus 1.683
पहले इम्पीडेंस टेस्टिंग करना
okay
so this minus 1.6 you
Has
are
to
giving
go-
you are
yeah.
giving randomly or
no OCP only I am applying go to the impedance spectroscopy method
Oh, first you are running OCP will give us
impedance spectroscopy method plus write down then FR impedance photostatic
sorry FRA
ये कहाँ से हो रहा है then FR impedance photostatic
FRA impedance potential static okay
okay apply the OCP here
apply voltage
हाँ apply voltage OCP you can apply OCP कितना आया था
माइनस 1.6 686
680
this one
so it has taken
627
OCP voltage okay
OC voltage you can get from direct from here itself go to the here
that is nothing but the cell potential right
हाँ just double click on this icon it will show the OCP here
which icon sir can you go back please
this icon instruments icon
instrument icon okay
otherwise here also option manual control
okay
minus 1.646 this is the open source potential
okay so when you click the home button it is showing all these things right
yes
this one
home then manual control
manual control okay the other options which you are telling was
double click here that also it will show
at the bottom in the home section at the bottom right
yes
okay okay sir go ahead
minus 1.642
it is varying sir
it will vary na it cannot be stable for a long time na that's why you are running the OC for 60 second or 80 second or 100 second that's why you are running na we are not doing any OCP study now we have to
that electrolyte concentration will also change na
yes time to time will change
it will change
minus 1.6 just take the current one it doesn't affect much now we are not doing OCP study apply this one minus 1.639 otherwise you have also another option is there put this parameter here command OCP command for 60 seconds then apply with respect to OCP so it will take this value automatically will apply to here it will do the 60 second OCP then it will go apply to with respect to OCP
okay Suresh,
हाँ सर.
you have to listen here.
Sir, one sample hand and practice sir you will perform sir.
After
Either
that,
eyes. Yes sir.
after that, because I have a
Yes.
meeting at 4 o'clock, you can discuss with him.
Yes sir.
Or you have to plan it. Tomorrow also he will come.
Yes.
Tomorrow we have to discuss further.
Okay. This thing with respect to OCP done. Then direct go to FRA measurement.
OCP done. Then FRA measurement. FRA measurement is impedance, right?
Yes.
FRA measurement.
First applied frequency means put the highest frequency. Then last apply means choose lowest.
It is standard. We have to use this thing or we have to change it.
Standard not. It is optimal value. You can change also.
Okay. So,
Maximum is for 6 year.
but sir, so now we are giving some value. For example, once the program is shut down and again we go back, it will automatically set into the default value, right?
It will be settled, but you can save this procedure also. It will save in as a my procedure. You can save this method also. File save.
Okay.
This is a method run. Data anyway it is saving, na?
No, that default value.
That's what I'm saying. Default value you can save. If you want to your customized data to save, you can save the procedure. Otherwise, it will go to the by default value always. Once it will close.
Every time it will go to the default value only. Okay.
But anyway, these are the not default only. It is actually customized. You have to change. Okay, so this parameter can change. Number of frequency put in 50 and frequency stability is logarithmic. How many points you need in between 1 lakh hertz to 0.1? How many frequency points you need? 50 points you need in logarithmic scale. In linear scale means linear scale will come.
Which scale we have to choose normally? Logarithmic.
Logarithm otherwise points per decay. Don't go for linear. Linear people don't like it.
And amplitude,
Amplitude look.
it 5 millivolt.
Amplitude 5 million. This much small.
Experiment पर ये थे.
No problem. You can give 5 to 25. You can give
अच्छा.
5 very small.
20
25 is very high also. And you have given 10. You see, he is telling 5. I can give 5. No problem. 5 millivolt na.
हाँ millivolt.
0.005.
अच्छा.
Then start it. It will take 229 seconds.
I need that recorded video. Back and right. How will you do?
Google.
एक चीज़ अच्छा टेस्टिंग फास्ट हो रहा है सर. दे डिड टेस्टिंग 4 hours per sample NIT Silchar.
I am Rahul.
That's what I am telling. So which is correct?
NIT सिलचर में तो नहीं है हमारा इंस्ट्रूमेंट.
हाँ सर.
NIT सिलचर में से अरुणाचल.
Silchar.
Silchar.
Assam. What machine you used there?
IBM software.
No, what machine?
Corrosion.
कितना फ्रीक्वेंसी है वो देखिए. ये यहाँ तक होगा. ये फ्रीक्वेंसी नहीं होगा. सब नॉइज फ्रीक्वेंसी है. ये भाई यहाँ तक देखना. ये जो 1600 ना 1600 ओम आ रहा है ना और उसका पोलराइजेशन रेजिस्टेंस वही है. इतना तक हो रहा है. वो वाला बाकी नहीं हो रहा है. नॉइज ले रहा है. तो इसके हिसाब से आप सिलेक्ट करिए. यू हैव टू सिलेक्ट एज पर दैट. इन दिस रेंज नथिंग इज all things will be noise.
What impedance will tell us, sir?
Impedance will tell you the capacity of that corrosion, means how much it can resist the corrosion. Higher the polarization resistance,
That is
lesser
already
the corrosion.
Corrosion, okay.
That one only. Polarization resistance you can measure in this impedance technique. That is the DC technique, this is the AC technique. Current.
It is flowing into the system.
Hertz na? Current is not flowing, hertz, frequency.
Frequency.
So
It will be like this.
it's a frequency scan. With frequency it will measure the impedance. So it will be more accurate compared to that one.
Compared to this.
Linear Tuffle-Stove technique. Because it's not applying anything na, so there is no harm to the surface. without doing anything, its impedance will not affect anything. Na? You are applying only the potential here. One definitely will take from there, not here. But still you know this one, you have to go for 1600 ohm. 1600 ohm is data, raw data. 1600 ohm, it will go up to here. 1570, 1600 ohm. It's a what ohm? Let's see. Z prime. So you have to do up to here, 828 hertz. Don't go more below that one. Understood, na sir?
Why you are
1 lakh to 828 hertz. So now in next analysis you will go for don't 800 hertz. From here, see it all are scattered data. Expand it.
okay.
You check
So until to the point where the scattering is not there, some trend is there. That point you have
up
to
to here
take.
it's okay, na?
Ah,
Where it is coming? This point, na?
that point.
1500, na? Up
Okay.
to approximately 1500, na?
1500.
Take the approximate one, na? Go to the this one.
Ah,
Check for near to 1500 where it is there. 1500 frequency, na?
okay.
This one, na? Up to 1500 is 1061.
Okay. So we have to.
Take that value only.
Okay. Now we have to again rerun the FRA, right?
Sorry, it is impedance, not frequency.
Ah,
1500 frequency. You have to get it from here. Z ohm 1500 frequency here.
okay.
This one. So मैंने ले लिया ना, so I have taken this 828 hertz.
828. Okay.
After that noise is coming. In lower frequency, general noise will come, not higher frequency. So I have started that one. Easy, na?
No, actually, this data where you have fed, can you just show it again? Just a minute. Can you stop and?
No, let it run. Here, the raw data, na?
No, I could understand. So you have gone for that particular symbol. Now, can you go to that sheet? Can you go to that sheet again?
This is the scene, na?
That data. You have taken that particular.
This one.
This one. Yeah. Here, you have gone for 1005. This one, right? So what is this? Z means impedance. What is this?
Impedance.
Huh?
Impedance. Z means impedance. Resistance.
This is minus Z. This is all. Is that double dash, right?
This is prime, that is double prime, that is a total impedance.
Total impedance.
It
Okay.
means it is theoretical, it's imaginary, there is total impedance.
Okay. So now we have to go with this one, or we have to go here with 1500.
Go with this one.
This one. This is Z prime, na? This is actual impedance. The curve shows Z prime or actual impedance.
All curve is there. Z versus Z, na?
Okay.
See, curve is Z versus Z, single prime, double prime. It's not total, it is a total impedance. Z versus frequency.
Okay.
All are meaning different, already mentioned clearly.
Okay. So this is Z prime only, right?
Z prime.
Z prime only. Okay, fine. So against Z prime, we are maintaining the after seeing the frequency, then what?
You are doing frequency star, not the resistance. So this resistance is coming with this frequency. So
with this
keep
frequency.
from this hertz to this hertz, you can do the analysis.
So the maximum frequency where you are entering, why you are running the experiment?
From the here, na 1 lakh. 1 lakh hertz is maximum frequency you are doing.
1 lakh to this one.
828.
828.
Already finished.
This data, sir, where you are entering this data?
See now how it came. Nice, na?
Hello.
ये नहीं लगा इसमें. इसका मैसेज अलग है.
No, तो सर
सर, डेटा में modification करना हो तो कैसे करेंगे?
ना मेरे को हिंदी समझ नहीं, थोड़ा स्लोली बात कीजिए, हाँ, ठीक है. तो आदमी आज आ रहा है ना, कर रहा है, थोड़ा करने के लिए बोलिए ना, थोड़ा करने के लिए, हाँ. थोड़ा पेंट भी करना है, थोड़ा पेंट अरेंज कर दीजिए। और वो क्या बोला, वो स्टील बार है ना, वो बार का ऊपर वो बुश भी लगाना पड़ेगा। वो भी थोड़ा बोल आप बोल दीजिए ना, आप तो मालिक है, थोड़ा बोल दीजिए। हाँ हाँ, ठीक है ठीक ठीक है ठीक 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 ठीक। So this is also possible here. Circuit designing.
Impedance is that one only, circuit design only.
Maybe we should just have a look on this. Sadish, நீங்களும் கொஞ்சம் clear-ஆ பாருங்க.
Okay, sir.
So after designing the circuit, the system will function in that manner.
Yes. So it is fitting there, na? You have to fix it, then it will fix here. First you have to do the circle fit. You have to make a half circle. Anyway, this circle is not half, it cannot be half circle. It is like straight line, na? It will not come half circle.
Something like a hyperbola.
Ah, so almost same straight line.
So again I'm asking.
वो ये वाला समझा ना आपने, बताया जो?
थोड़ा एक मिनट है, थोड़ा बहुत कंफ्यूजन है।
ये रहा।
अप्लाई 0 वोल्ट, उधर आप फ्रीक्वेंसी मेंशन कर रहा है, ठीक है? So while you are actually running the things, in this after finalizing the frequency, you are giving the frequency value in this area only, na?
Where,
The
sir?
frequency 860 hertz.
It's already applied, na? This OC measure, this OC will be applied here.
No, I couldn't able to recollect where you are giving the data 868 to 1 lakh hertz.
Where I'm giving this one FRA measure here only.
That's what I'm asking. FRA you are giving 800 to last applied frequency is 800. Okay. First applied frequency is 1 lakh hertz, right?
Yes, here only we are giving.
Okay. After that you are giving this data. Then you are starting the. Okay.
This is the data. No, you cannot start it. You have to start it from procedure window. This is the data window. This is the procedure window.
Okay. So after giving the data here, then you are going for starting option. Okay, fine. Now coming to the impedance one, data. Okay, this is the one, right?
Everywhere after wait command, na, this is the parental command where you can edit everything data. See, after CV you have seen the CV staircase, LSB staircase. In polarization LSB staircase was na. That after immediately after wait, this is FRA measurement. This is a parent command where you have to put all parameters.
Here, can I press it now?
This is a data window. You cannot edit anything. Yeah.
So there you are telling FRA measurement. This is the thing. Okay. Once it is run, now you are having the final data, right?
Yes. You can run it.
Huh?
Run it. No problem.
Okay. So now here you are creating the circuit. What is the need of creating the circuit?
That's required paper demand. You have to give a circuit, na? That requirement of paper only.
Actually, in our welding paper so far, no one has given the circuit, na? Why?
Sir, we need to analyze, sir.
You are doing corrosion studies now. You have to tell.
No, if they will give corrosion, then circuit is not there. If you are giving impedance, spectroscopy, it will ask, then you have to give the circuit.
Why you want impedance? For your saying.
Why you want impedance?
What?
Huh?
For the means resistance, the polarization resistance that can be related to the impedance.
Okay.
So if I in the paper, if I put the data of polarization resistance, then impedance
Polarization resistance, impedance both are same. Okay. Impedance other name is resistance. While you are telling in terms of DC, name will be resistance. When AC is coming, means alternating current, then impedance term will come. Both are similar. Polarization resistance itself, the sample resistance it is telling. Okay, so impedance and resistance both are same parameter. Don't confuse.
No, it's fine. So that Again, I'm asking this particular thing is operating with respect to the DC supply. The entire unit is operating with the DC supply, right?
But the impedance FR is AC only, not DC. FR that impedance, hertz is there, na? When frequency is coming, it is not a DC, it is AC. All other techniques are DC only. Only this impedance spectroscopy is a AC technique, not DC.
So here the applied voltage is, we are giving in milliamps only. Milliamps only, right?
No, here we are not applying any voltage. Many ampere.
That's what I'm telling. We are applying in milliamps only.
Not millivolt, not amp.
We are giving in voltage here.
Sir, here there is no current. You are telling on impedance spectroscopy or any other technique?
Impedance only.
Impedance, where is the current? Where there is no current.
No voltage also.
Voltage also not, we are applying that this OCP only, nothing else. Just OCP just applying. It's that OCP we are applying, not means we are not doing anything.
So OCP is the resistance that is automatically.
No, we cannot apply 0 volt. 0 volt you are applying means then you are applying negative one.
Fine.
Understood? No?
We are giving the cell potential value as
I will
the.
tell you the simple thing.
No, now I understand.
Yes, okay.
The cell is having a potential. That potential we are applying.
If you were applying 0, definitely you are applying. By mistake, suppose you are putting 0 volt applying means cell itself showing it is minus 1.6 volt. We are applying 0 means we are applying minus 1.6 volt.
So
It means
we are giving minus 1.6 volt, which is the cell's potential. From
Yes.
there, we are going further in evaluating the impedance.
exactly. We are not without doing anything. We are measuring the impedance.
Okay.
So that's why compared to polarization technique, it's more accurate compared to that.
And the circuits which you are changing here and there like that, na?
That is actually for research analysis only.
So that is like iteration only.
That doesn't really require. If you don't want to put in a welding paper, may not require. That is for more analysis purposes only, research purposes only.
What is needed, we have to look into that aspect.
See, I am telling that corrosion analysis circuit. Why I am also telling, Oil India they are doing. They don't need circuit because that same thing welding things you are telling that they have pipe and that oil is going, that crude oil. Crude oil doesn't contain 100%. Hardly 5%, 10% will come. More rest will be alkaline water will be there. So they are taking that as a solvent, electrolyte, and their sample means mild steel that pipe little bit they are taking. They are polishing, they are measuring. This simple thing they are doing this one only. That's it. FR measurement, they are doing this electrochemical circle fit. Electrochemical circle fit means they have to measure make a half circle. It's not coming. Then they have to measure the polarization resistance, this one, RPR.
Okay.
Simple thing, they are not interested in circuit.
Okay. Girish, you can change the sample and you just see the demo completely.
Sir.
Okay. Sir, I have a meeting at 4 o'clock. I'm just going for that. You can try with the other sample.
Yes, sir.
Just have the clear idea and then you work on this sample today.
Yes, sir. Hand sample.
Just you do 2 to 3, you give adequate
Yes.
operation
Okay, sir.
and you also chalk it out the procedure so that tomorrow you can again discuss with him.
Sir.
We can discuss with him.
Yes, sir.
Okay. So I'm just going for a meeting. Meeting with the registrars.